All right, how we're going to find the difference quotient given a function. What I usually like to do on these problems is I like to break them up into pieces. So I start with this first piece here, f of x plus h. I take f of x plus h off to the side and I work that out. And in working that out, I understand that whatever I have in this little set of parentheses here, that x plus h, that's going to replace the x's back in the original function. So in the original function, I only have that 1x there. So that 1x I'm going to replace with the x plus h expression I need to substitute right here. Everything else that surrounds that x in the original function just kind of comes along for the ride. Now once I do that substitution, go ahead and do some distributing here. If I distribute that negative 4 through, got negative 4x minus 4h. We go ahead and get those terms kind of out in the open to work with. Basically, f of x plus h in a simplified form is that 3 minus 4x minus 4h. Now the other piece of this puzzle is the f of x part. Now, since that's just f of x, we've got f of x right up here. We know that f of x is 3 minus 4x. So if I want to put this all together to figure out what f of x plus h minus f of x over h is equal to, take that first piece, take that f of x plus h that we found over here. I'm going to substitute that in for this part. It's going to be 3 minus 4x minus 4h. So all of that is f of x plus h. I'm subtracting, well, f of x was this part, right? The blue part. I'm subtracting that quantity of 3 minus 4x, all of which is over h. Now, if we're going through and we're simplifying these correctly, ultimately what should happen is the h down here in the denominator should cancel out somehow. That's how we know we're doing this correctly. So when I start joining like terms in the numerator, I carry my negative through, so I change my signs. Notice that the terms which cancel out are the non-h terms. That's what should happen. The only terms that should be left on top should have an h in them. And if that's all over h, we can now cancel the h's, meaning our answer here for the difference quotient is negative 4. All right, so difference quotient again, this time f of x is going to equal 2x squared minus x. And if I'm consistent with what I did from before, knowing that ultimately I want to find f of x plus h minus f of x over h, what I did before was break it up into pieces, start by figuring out what f of x plus h is. To figure that out, I go over here. I appreciate that the x plus h is what has to go back in the place of x in the original function. So here I've got a couple of x's. So I'll substitute x plus h in for both of those. We'll have 2 times x plus h as a quantity squared minus the quantity of x plus h. So in the previous problem, we did some distributing, right? Here we're going to have to do some of the same things, but first it would be smart to expand that binomial out. Right? X plus h squared is the same as x plus h times x plus h if I do some scratch work down here. Now some of us might recall as a perfect square, what we end up getting back is x squared plus 2hx plus h squared. But even if you don't remember how to go from here to here, we can at least FOIL that out to get the same result. But long story short, this x squared plus 2hx plus h squared goes back in the place up here, which is multiplied to 2. So if you want to go ahead and distribute that through as you bring it back up here, you could. But if I write out the step, that's how it would look. Still subtracting this quantity of x plus h. I'm kind of holding off on that for the time being because I'll do my distributing all at once. Now if I distribute the 2 through. I've got 2x squared plus 4hx plus 2h squared. And this negative goes through the x plus h, right? So it changes the signs to minus x minus h. Basically, this guy right here is what I want to bring over and now substitute in the place of the x plus h that I have over here on the difference quotient. So when that goes in, I'm going to have to bring this down a little bit. I'm going to run out of room. Set up a line here. F of x plus h. Get 2x squared plus 4hx plus 2h squared minus x minus h. There's your f of x plus h. We are subtracting from that f of x. F of x is the original function. So all we need to do now is take this original function and bring it down as a quantity. So slap some parentheses on there. Got 2x squared minus h, or not h, sorry, x, that we're writing down here. This is all over, and don't forget that this is all over h. We've got our pieces in place. We're ready to collect like terms. Like I explained on the last one, if we're doing this correctly, we should notice as you carry that negative through and start collecting like terms that a lot of the terms that don't have h's in them, they're going to go away. So notice the 2x squared, that's gone. The x, that's gone. And hey, what do you know? We've got a term that's got an h in it of 4hx, another term with an h in it, 2h squared, and finally a term of minus h, all over h. Now how you cancel out these h's at this point is up to you. You could factor an h out of the top and then cancel, or you could divide this h into every term. As long as you're dividing into every term, that's okay. If I just divide into every term, h goes into the first term, h's cancel out. I'm left with 4x. H goes into the next term. I've got 1h that's going to be left up here, so it's going to be plus 2h. And then h goes in the last term. We're subtracting here, since those cancel out, 1 will hold its place. There's your difference quotient on this one.